Hello, students. No, I did not forget to change my paper. I wanted to talk a little bit more about this. So, I want to ask you, what is it about 2, 3, and 4 that made them bad here? And one thing you might say, and stop, think about your answer. I wish I could hear it right now, but I can't. But what we can do is we could say, hey, I'll admit, usually somebody in the class says, hey, 2 divides 6, and 3 divides 6. But 4 does not divide 6. So it's not the numbers that divide 6 that get kicked out here. So what can we say about 4 and 6 that we can't say about 1 and 6 and 5 and 6? And that is, even though 4 and 6, one doesn't divide the other, they share a divisor. The GCD of 4 and 6 is not 1, but the GCD of 1 and 6 and the GCD of 5 and 6, they're both 1. So, in this case at least, we kick out all the numbers where the GCD is not 1. Same thing here. What do you mean? You can't take the GCD of 0? Sure you can. You could take the GCD. What's the greatest common divisor? What are the divisors of 0 and 6? You might say, well, 0 doesn't divide things. You're correct. But you can still take the GCD. I'm not saying the GCD is 0. I'm saying you can take the GCD of 0 and 5. And what is that? It's the greatest number that divides both of these. Well, that would be 5, because you can't get bigger than 5 and still divide 5, and 5 divides 0 perfectly fine. So, what do we have here? We have the GCD of 0 and 5 is 5, and that got kicked out because it wasn't 1. So what we do is we throw out all the elements that share a divisor, or all the elements where the GCD is bigger than 1, or, we have a special word for this, some of you may know it, we throw out the things that are not relatively prime, and we keep the things that are relatively prime. So relatively prime just means the GCD of the numbers is 1. And that's how we create UN. We only take elements. I mean, we're still going to be taking the elements from Zn, right? Because we're doing modular arithmetic, for which they are relatively prime, meaning the GCD of K and N is 1. So that's a rule that we can use in general. So for example, when we are in U4, well, the GCD of 2 and 4 is 2, the GCD of 0 and 4 is 4, those needed to get kicked out. So we could see that right off the bat. So using this technique, we can create groups, like this nice group over here, U5. And whole families of groups because we have infinitely many. Now notice, of course, UN is not going to be size n. It's never going to be size n. We're always going to have to kick out at least 0, and it's not always going to be n minus 1. It is going to be n minus 1 whenever the number is prime. So 5 is a prime number, and if you did the example for 7, which is also a prime number, you will also get 6 elements. So if we have a prime number, you're not going to have anything between 1 and that number, that prime, which has a GCD greater than 1, because it has no divisors other than 1 and itself, no positive divisors, at least. So because of that, primes, U mod a prime, they're going to be big groups, 1 less than the size of n in general. And that's a very lightning fast introduction to groups of the form UN.